our problem statement title, that is smart water pressure management for the equitable water supply in the Solapur Municipal Corporation. Okay, and the proposed solution is that that we are going to develop the IoT enable the smart mini zone water management system, monitoring the actually the flow and the pressure. Okay, in the real time using the multiple sensors. Okay, so we are just making for the mini zone. Okay, to actually get the inlet and outlet. Okay, what actually the pressure is going to be handled and all. So how we can address the problem. Okay, so the IoT enable the API based system with real-time visibility to the CMC instead of the complaint operation. Okay, and here is a process flow diagram that how it actually works using the zone inlet blocks, distribution pipes, and all the inlet outlet pressure is going to be measured. And after that, the firebase and the data flow is given. And the hardware and the sensor that we actually use on a project. So that is a pressure or the flow sensors for the real-time pressure monitoring and the leakage detection, and the ESP32 okay for the data collection and the transmission, and the automated valves okay so for the on off, and auto hold on okay so to actually which can the measure the pressure and allow the hose okay so for the water flow and to stop. So methodology having the block flow such as the start initializing system sensors ESP32 cloud server data analysis, and also after there is a decision making okay so after the appropriate the coding is going to be done in that, and the softwares and the tools like HTML CSS JavaScript database okay having the Firebase, and also the EPRs the cloud platform the Google Cloud that we actually use on a project, and the visualization the chart.js, and the moreover the process flow of the block diagram like in the software that the Python not the processing is there like backend APIs front end, and also the Firebase they are actually described over here. After that the feasibility and the uh, viability. Okay, so after analysis we actually get the low cost the harvests okay so to make it the viable okay so or the user friendly, we can also integrate with the existing gravity based water infrastructure because in the Solapur there are actually the hilly regions and also the low regions okay so according to that we have to adjust the pressure and the flow okay so automate the water system, and also the which require the minimal civil changes like sensor plus the wall installation only, and the modular the meso architecture allows the phase implementation and the proven the IoT and the cloud technologies they ensure technical stability. So in the user case diagram we can actually get the idea that how the project or how the sensor actually going to be work okay so with the operator okay so get the access of the dashboard okay so here we can actually get the idea regarding the water pressure and all that how is the water pressure then and how we can control it okay, and also from the dashboard user okay so here we provide the data and matrix okay so regarding the water flow okay so for the specific region like hilly regions and low regions okay so according to era so we can access the information, and so that we can actually get the proper idea regarding the water pressure and the uses of water okay so in the potential the challenges and the risks okay the sensor accuracy and the long-term calibration issues okay so but it might be get fixed in the future. The network connectivity issues in the underground installations, and the power ability for the sensors resistance to the adoption from the municipal authorities, the false leakage alerts due to the sudden demand changes, and the moreover the strategy for the overcome the challenges like using the industrial gate sensor with the periodic calibrations and the local SP32 edge processing to handle the temporary network failures, the low power design with the battery. So we can further innovate like using the solar backups or the solar panel to integrate with the AI and all. Okay, so for the more reliability and to get a proper output, and also the combined pressures flow analysis to reduce the false leakage detection and all, we can actually detect the pressure level. So in the impact and benefits, so in the potential impact on the target audience, ensure the fair and the reliable water supply to all the areas okay so including the tail and the user, so they help the municipal authorities and monitor and control the network in the real time okay so we also reduce the manual intervention and the improve the decision making efficiency. In the technical impact also the sensor automated the wall control and IoT make the proper sense of using the water usage and also to measure the pressure over here. User experience okay the reliable water supply and fewer descriptions, and the most important, there is an equal amount of the pressure is water going to be delivered, okay, so in the every region, like it may be hill and so low region. Okay, so equality is going to be done in the water supplement, and the operational impact like reduce the manual checks and the faster decision making, the lower maintenance workload and the efficient resource uses. And the future scope like the we can integrate with AI, smart city integration or the expansion to solar panels. Okay, so there are the more further innovation we can made in this project. Okay, so we can actually work on it. And the benefits of the solution like social benefits like equal water access to all the communities and reduce the water scarcity complaints, improve the quality of life in the high risks and the teen areas. The economic benefits reduce the water losses and the leakage related cost, lower operational and the maintenance expenses, the better utilization of the existing infrastructure, and also there are the environmental benefits like conservation of the water resources, the reduced waste and the non-revenue water and support sustainable and responsible water management. Okay, so further we can see the research and references. Okay, so here are some research that are actually used to get for the primary research and for the data collection. And the more we actually use some of the patent grant or by the more or the water distribution monitoring systems, and also the IoT built most of project, okay, so which are granted by the, okay, so well renowned platforms. Okay, thank you.